Alright guys, so today we're going to continue on 5.4 simplifying radicals. Now what we're going to do here is instead of continuing to solve quadratics, we are going to learn a skill that's essential so that when we solve quadratics in the future, we know how to simplify radicals. So you can kind of see where we're going. You need to know how to simplify radicals so when we get to it in the future, you know how. So what is a radical? Let's just start with that. Now mostly everybody knows that a radical is just a square root. I just wrote it over here so that way we can kind of see it. That is a radical, and a radical is a square root. In the operation it performs, it's asking you, hey, if I'm taking the square root of something in the inside, I want to know what multiplies itself to equal that inside. So if I ask you to complete the entry test 1 from 1 to 3, all I'm asking you to do is to perform the radical, to perform the square root. So let's look at this first one here. I have a square root of 36, aka I want you to come up with a number that multiplies itself to 36. And what multiplies itself to equal to 36? And that answer would be a 6. So the square root of 36 is 6. Not the square root of 6, but 6, because 6 times 6, 6 times itself equals 36. Now let's go on to 3. And I'll show you why we skipped 2 in a second. If I'm taking the square root of 49, I am asking you to perform the operation or to think of a number that multiplies itself to 49. Now, does there exist a number that multiplies itself to 49? And the answer is yes, it would be 7. So the square root of 49 is 7. Now, let's take the square root of 24. Does there exist a number that multiplies itself to equal 24? No, there's nothing, at least a whole number that does. There's probably something that adds, right? 12 plus 12 is 24. But again, we're asking ourselves what times itself. And that is our main goal today, is to learn how to simplify problems like this. And remember, simplifying just means to make something look simpler. So when we took the square root of 36 and we said it equals 6, we simplified it. We made it look simpler than what it is. And our goal today is to how are we going to simplify situations like this. Now, what's something that's going to be absolutely key for you guys today is to know what these perfect squares are. Now, perfect squares are numbers that have a number that multiplies itself to equal that. So 1, 4 are perfect squares, 9 and 16 are perfect squares, 25 and 36. Again, 25 is a perfect square because there exists a number that multiplies itself to equal that number. That number would be 5. 49, 64, 81, and 100, 121, and 144, those are all perfect squares. Now, you can see why those perfect squares are absolutely important and why you should write these down so that way you have a list of them right next to you when you're simplifying. And that is because if there is a number that multiplies itself to equal these perfect squares, these numbers we keep talking about, you can take the square root of any of those numbers and you would get a whole number. For instance, let's look at 81. The square root of 81 is 9. Whenever you take the square root of a perfect square, you're going to get a whole number. Notice that if you don't take the square root of a whole number, or one of these perfect squares, let's say 3, there doesn't exist a number that multiplies itself to 3. So that's why these numbers that are circled are going to be really, really important. And if you don't have them memorized, I would write down the 7 squared because that kind of helps you see what number times itself twice equals that number. So make sure you write those perfect squares. They're going to be super important for you when we are going through simplifying radicals. So let's start with just a property before we start diving into that. So there are 2 properties of square roots that you absolutely have to be comfortable with. So let's assume that for any non-negative real number a and b, so any number that's non-negative, just think of a number and let's call them a and b. The following properties hold true. If I take the square root of some number times some number, that equals the same thing as the square root of one of those numbers times the square root of the other number. So pretty much using math terms, if I am taking the square root of a product of 2 numbers, I can actually split the square roots and take the product of each of those numbers first. So for instance, let me show you a real world example. Let's say I have the square root of 4 times 9. Now, I see I'm taking the square root of 4 times 9. What I could do is I could split the square root of 4 and 9. Because again, these are the product, I'm taking the square root of them. I could take the square root of both of them. The square root of 4 is 2, square root of 9 is 3. And I can see that 2 times 3 is 6. Now, Let's say in the beginning I would have just done the 4 times the 9, which equals 36. Let me write that a little nicer so that way you can see it. So what I did there is to simplify the inside of the radical. 4 times 9 is 36. And is 36 a perfect square root? Yes, because what number exists that multiplies itself to 36? It'd be 6. You get the exact same answer. So again, this is just a property so that way you can see it. If I was writing this down on my notes, all I would write is, okay, this is equal to the square root of a times the square root of b. And you'll see why it's super important. That was just an obvious way to show you how it works. And the nice thing about this, it also works within quotient of, if you're taking the square root of a quotient, or some things that are dividing themselves. If you are taking the square root of two numbers that are dividing themselves, like a and b there, you can actually divide them separately. Just separate the numerator and denominator, take the square root of both of them, and you can actually simplify from there. So again, these two square roots, or these two properties, are going to be absolutely key for today, because we're going to start solving and simplifying. We're not really solving, we're simplifying problems like 1 through 4 right here, and I'll show you exactly what I want to see when you guys simplify these. So let's start with number 1. Notice I have the square root of 50. Now, is 50, does there exist a number that multiplies itself to equal 50? And a lot of people, when they're in a hurry, they'll say, oh, it's 25. But remember, 25 plus 25 is 50. But there doesn't exist a whole number that multiplies itself to 50. So we have to simplify. And this is how you make this number look simpler. Look at all your perfect squares. And that's why it's important to have all these perfect squares, so that way you can see them. Can we rewrite 50 as a product, aka something times something, of one of these perfect squares and some random number to equal 50? And I'm looking through this and I can see that actually 25. We could rewrite the square root of 50 as 25 times 2. And keep in mind what I did there is I just looked down my list of perfect squares and I said, hey, how can I rewrite one of these perfect squares as a multiple of 50? And then my answer would be 25. It kind of popped out to me because 25 times 2 is 50. Now remember our properties. If we're taking the square root of two products within a square root, we could separate and take the square root of each. So let's do that, because these are just multiplying. So the square root of 25 times the square root of 2. And let's see if we can simplify these. What is the square root of 25? What times itself equals 5? I believe that's a 5 hidden in my scribbles. And what is the square root of 2? When there is no 2, notice you cannot rewrite it in any way, shape, or form as a product of any of these perfect squares. So that means that this is as simplified as you can get it. You are done. Now, some might argue, does that really look any simpler, a square root of 50? I don't know, but this is the standard, so we have to do it. All right, so let's go to the next one. Notice I have the square root of 11 over 49, 11 divided by 49. Remember that you can simplify these just by separating the numerator and denominator and taking the square root of the mentioned numerator and denominator. Now, is 11 a perfect square root? I'm looking at my list, it isn't. Can I rewrite 11 as a product of one of these perfect squares? And the answer would be no. So that means that is as simplified as it could get. I can move on to the 49. Now, is 49 a perfect square? And if you're lucky, it is, which in this situation it is, because the square root of 49 is 7. So, square root of 11 over 49 can simplify to the square root of 11 over 7. And that's pretty much it. Now, I'm going to erase this just to have a little bit more room for the other ones. All right, so square root of 49, or 45, sorry. 45. Is there a perfect square? And I'm looking at my list over here, by the way, and I cannot see a 45. But can I rewrite 45 as a product, as a multiple of one of these perfect squares? And I believe 9 would, because 9 times 5 is 49. Notice I'm going to take the square root of those two products, because all I did was rewrite 45. And now I just need to separate my two square roots using the property mentioned above. And just simplify your life away. What is the square root of 9? It would be 3. The square root of 5 would be 4. So, square root of 45 simplifies to 3 square root of 5. All right. Last but not least, this is a very stereotypical kind of challenging one, I would say, because there's multiple simplifications within the problem. Now, whenever I see a fraction, the first thing I like to do is just separate the numerator and denominator with my square roots. And then I ask myself, hey, are any of these square roots, whether in the numerator or the denominator, are they perfect squares? And I can see that 81 is. So I have the square root of 32 over square root of 9. Let me make sure I leave a little space there so you can see that's equal sign. Now, some people might be like, all right, cool, I'm done. But remember that you have to simplify each radical. Yes, we simplified the square root of 81 just to equal 9, but can we simplify the square root of 32 in any way, shape, or form? Is 32 a perfect square? I'm looking at my list, and it's not. But can I rewrite it as a product? Notice that 4 and 16 both go into 32, but always go with the biggest number so that way you don't create more work that's needed for you. Start with the biggest number. So I'm going to rewrite that 32 as 16 times 2. Now, in order to make sure I'm not messing things up, I'm just going to rewrite the numerator over and over. I'm going to separate these. So the square root of 16 times the square root of 2, still all over 9. And I'm just going to simplify now. Now, hopefully you can see this a little bit better here because the square root of 16 is just a positive 4. The square root of 2 cannot be simplified, so I'm going to leave it as 2, and then the 9 goes at the bottom. So, trying to show it to you in the dark right there. 4 square root of 2 and the 9 there. So, again, some of you guys might argue, excuse me, is it really any of that simpler? And I don't know what the answer would be. But again, you have to do this in order to be considered, at least mathematically. All right, so let's go into a little bit more. So that's how you simplify numerical numbers. You just got to remember those two properties. But now let's get to variables, because as you can see, we're going to have to do both later in the same radical. So let's go ahead and do that here. So these are a little bit tricky, and there's so many ways to think of them. I'm going to show you all 4, and then I'm going to show you which way works out best for me. So notice here that I'm taking the square root of x to the 6. So what times itself equals x to the 6? And I believe that answer would be x to the 3rd. Because x to the 3rd times x to the 3rd is x to the 6. What did I do there? What's an easy way to think about it? Well, I know I'm multiplying something by itself twice, because I'm multiplying by itself, right? So you multiply something twice. What I like to do is think of it as a 2. And I'm going to put a little, what is known as an index there, to say, hey, what is 6 divided by 2? And the answer is 3, because you're asking yourself, how many groups of 2 are there? How many times is it multiplying itself? 3 times, so it's x to the 3. Now, there's other ways of thinking about it. Let's say we're taking the square root of x to the 6. Well, that's just x times x times x times x times x times x 6 times. How many groups of 3 do you have? 1, 2, 3. I'm not sure if I said groups of 3, but I try to say groups of 2, because remember, we're multiplying by itself 2 times. That's what a square root is. And there's 1 group of 2, 2 groups of 2, 3 groups of 3. So that means that there is an x to the 3. What other way is there? I think those are the most popular ones. And you might be asking, why in the world is this guy going into such detail? Because it gets a little tricky once you start doing odd numbers. Because notice we're taking the square root of 5. Can we divide 5 by 2? No. But how many times does 2 go into 5? How many times in total does it go? And I would say it goes 2 times. So what I like to do is write my square root. I like to say, okay, if it goes in 2 times, 2 goes into, that means there are 2 groups. There's x to the 2 groups. Now, if there's 2 groups, how much is that in total? That'd be 4. That means you have 1 left over where you can't multiply it by itself. Now that's where it gets challenging because it's hard to visually see that. Let's do it by writing out those 5s, or those x's 5 times. So x to the 5th is just x times itself 5 times. How many groups of 2 do you have? 1, 2. Notice that this little guy is a loner. It doesn't have another group of 2, so you can't really take it out. How many groups do you have? You have 2 groups. You took them out. You have 1 x left over. Now, of course, you're not going to want to keep writing those x's out, especially when you get to 11 in this problem. So my suggestion is to try to formalize a strategy. Again, what I like to do, and write this bigger for some reason, I feel like it's going to make more sense. And I ask myself, hey, what is 5 divided by 2? Because again, you're asking for something times itself. So how many groups of 2 does it have? I can see there that 2 goes into 5 2 times. 2 times 2 is 4, so that means you have 1 left over. So think of the remainder. You only have 1 left over, so that means if you have 2 whole groups, 2 whole groups are going to come out, and 1 is going to be left over. And that's how you do those ones over and over. Now they are going to do this with multiple variables, so you need to make sure that you got your game down in a way. Let's see how many. And this is what I like to do. I always like to do my square root and think of things coming out of the square root. If you have 8 x's, how many groups of 2 do you have? Well, what's 8 divided by 2? It's 4. So that means you have an x to the 4 that comes out, which makes sense because what times itself equals x to the 8? X to the 4. Now you have 4 y's. If you have 4 y's, how many groups of 2 do you have? Well, that's just division. 4 divided by 2 is 2. So that means you have a y to the 2, which makes sense because, again, y to the 2 times y to the 2 is y to the 4. Notice that I really wrote this for no reason. You can either erase it because there's nothing left in that square root. Let's keep going a little further. You have x to the 11. How many times does 2 go into 11? Well, it goes a total of 5 times. Now, 2 times 5 is 10, so that means I have 1 left over. You have 6 y's. How many groups of 2 do you have? You have 3. So that means that you have 3 groups of 2, and that's pretty much it. That's as simplified as it could get, and you're pretty much done. All right, so let's do this pretty lengthy. We have variables, and we also have numbers, but again, it's the same stuff. Look at your list. What's the biggest number, or what's the biggest perfect square that can be written as a product of 125? You'll see that 25 times 5 could equal 125, and then I just rewrite my variables over. And just like before, I ask myself, what can I take out? And while I'm taking those things out, I'm going to leave them outside my radical. Let's start with 25. The square root of 25 is 5, so that means that's out of there. What's the square root of 5? Well, it isn't a perfect square, and we cannot rewrite it as a product, so it gets left inside. We have x to the 5th. Remember, when you're dealing with variables, how many groups of 2 do you have? Well, I have 2 groups of 2 because I have 4, and then I would have 1 left over, so this is your simplified answer. Let's go ahead and do the next one, because these are just all practice. 27, is it a perfect square root? The answer is no, but I can rewrite it as a product of a perfect square, which is 9. And then I go ahead and rewrite everything, and then I just go step by step. The square root of 9 is 3. I cannot take the square root of 3, so I leave it inside. How many groups of 2 do I have in 7a's? And I believe that would be 3, because 2 times 3 is 6, and then I would have the 1 left over a. Now you have 8b's. How many groups of 2 do you have? You have 4, so that means that this would be your simplified radical there. All right, so keep going there for a second. What I'm going to do here is take out a calculator because I want to show you guys how you guys could solve these when perfect squares or your multiplication isn't as, how would I say, as obvious as other times. Now here's my list of my perfect squares. Notice that I have 216. I don't know in my head what perfect square goes into them. So what I'm going to do here is I'm going to take out my calculator and just literally start dividing by the perfect squares. 216 divided by 4 equals 54. That means that 4 times 54 equals 216, which is awesome. Just go through your calculators. Remember, we're trying to find the biggest one, so let's try a bigger one. The next one is 9. Let's see if 9 goes into there. 9 also goes into there. So that's pretty cool. Let's see if we can find a bigger one. 216 divided by 16. We get a fraction, so that means that that isn't divisible. What's the next one? There's 16, there's 25. How about 36? Let's see if 36 goes into it. And it does. So that is pretty much as big as it can go, 36 times 6. Again, when you can't see these perfect squares dividing or as a factor, just start dividing them in. And as soon as you get a whole number out, that means that those are factors. So 36 times 6 equals 216. Let's go back and do our math now. So simplifying 216, that is going to simplify to 36 times 6. My y to the 4th is just hanging out. The square root of 36 is 6. Can I take the square root of 6? No. Can I rewrite it as a product of a perfect square? And the answer would be no too. Now, 4 y's, that means that you have groups of 2's, and that's it. You're pretty much done. All right, one more. So I'm looking at this one. I can see that 4 goes into it, but again, try your biggest one, which is 16 times 2. Take out the 16, you end up with a 4. Because again, there's a number that's a perfect square. 4 times 4 times itself. 2 stays the same. You have 5 x's, so that means you have 2 groups of 2. That means that you have 4 of them, and then you're left with 1x over, and that's it. So I know this video is getting lengthy, but you'll notice that these ones are almost done now, because you need to know how to add and subtract them. And adding and subtracting is really, really easy, and I'll show you how. So when you're adding and subtracting radicals, they're kind of like variables. You can only add or subtract the radicals that are the same. So if you have a square root of x plus the square root of x, well, how many square root of x's do you have? You have 2 square root of x. You can add them up. Think of them as the leading coefficient as 1. 1 square root of x plus 1 square root of x equals 2 square root of x. And the same thing goes with pretty much subtracting. Notice we have 5 square root of x minus incognito 1 square root of x. Well, these are the same square root. So if you have 5 and you take away 1, you have 4 square root of x's. Now, do we know what the square root of x plus the square root of y is? And the answer is no, because those are not the same square roots. So you have to leave them exactly like that. They're already simplified. Same thing with subtraction. Notice that these square roots are not exactly the same. So you have to leave them just like that. There's no way to simplify them. Now let's throw some numbers in here. I have the square root of 2 plus the square root of 2. Now remember, leave those ones out there if they help you. You have the square root of 2 plus square root of 2, which is 2 times square root of 2. Keep in mind that I'm not adding the insides of the square roots. I'm kind of treating them as variables. Now, square root of 2 plus square root of 3, can I add these? Well, no, because these square roots are not the same. So the only way to write them is to rewrite them over. Now, let's look at this one. Square root of 3 times square root of, or 3 times square root of 3 minus square root of 27. Now, those aren't the same. But can I simplify these? Yes, I can. Now, this one is simplified as possible, so I'm just going to leave it like that. But how can I simplify square root of 27? And I'm going to do that in red over here. Out of the square root of 7, which perfect square goes in? 3. 9, because 9 times 3 equals 27, and the square root of 9 is 3. Notice that your 3 stays inside. So all I did there is I simplified it. And now am I ready to subtract these? And the answer is yes, because I have 3 square root of 3 minus 3 square root of 3. So if you have 3, you took away 3, you end up with 0. So pretty much always simplify your radicals and then do the math. So I can clearly see here that I have a square root of 2. I can't simplify that, but I do have square root of 8. So let me write this over here to do my math separately. I'm going to rewrite 8 as 4 times 2 because 4 is a perfect square, and that's my goal. Now, in order to take out the 4, I need to take the square root of it. Square root of 4 is 2, but there's already a negative 2. But remember, those are just multiplying. So negative 2 times 2 is a negative 4. So that came out. This 2 stays inside, and that is what that simplifies to. Negative 4 square root of 2 plus 5 square root of 2. Negative 4 plus 5, because again, these are the same radicals, so I could add them up. I'm going to end up with a positive 1 square root of 2. I'm going to leave the 1 out because there's no need to write it. All right, next one. 24. My suggestion is to always do the simplification to the side, so that way you can see it and not be confused. So 6 square root of 24, I'm thinking what perfect square goes into 24? I believe it would be 4 and 6. Yep. When you take out that 4, it becomes a 2 because you're taking the square root of that. 2 times 6 is 12, so then that 6 stays inside. So I end up with 12 square root of 6 plus 5 square root of 6, and that becomes 17 square root of 6. All right, so 8. Let's simplify 8 in the next problem. I have 4 and 2. Square root of 4 is 2, and then square root of 2. I can see there that I forgot my negative 2 out in front. So I'm going to rewrite my negative 2 all the way out. I see that they're multiplying, so it ends up with a negative 4 square root of 2. So negative 4 square root of 2 plus 5 square root of 3. Are these the same radicals? No, we pretty much simplified for no reason whatsoever. Unfortunately for us, that kind of sucks there. So I did feel like if you understood what I did there with simplifying the square root of 8, you could stop watching the video here. I feel like I kind of did it rushed because I feel like this video is coming along. So I'm going to explain it again so that way hopefully it's clear. So I looked at that guy and I want to simplify it. So I end up with negative 2 square root of what perfect square? And it would be 4 times 2. Now when you take out the square root of 4, it becomes a 2. 2 times a negative 2 is a negative 4. You're left with that square root of 2 in the inside and you're done. So that's pretty much all. And hopefully that's it.